So here we have y is f of g of h of x. We want to determine dy dx. So let's remind ourselves, what is the derivative with respect to x of f of something? That is f prime of the something times the derivative of the something. That's going to be our key idea here to actually evaluate this. That is a version of the chain rule. So if instead I write the derivative with respect to x of f of g of h of x, g of h of x is now my something. So what will that be? That will be f prime of g of h of x times the derivative with respect to x of g of h of x. But I hope that doesn't cause too many problems, because what is the derivative of g of h of x? What is the derivative with respect to x of g of h of x? The derivative of g of something is g prime of the something times the derivative of the something. So in this case, my something is h of x. So I have g prime of h of x times the derivative with respect to x of h of x. So what I get for that piece is the derivative with respect to x of g of h of x is g prime of h of x. The derivative with respect to x of h of x is just h prime of x. So we're going to plug that in there for this piece. Notice, what did we have before? We had the derivative with respect to x of f of g of h of x, parentheses, 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 bracket, is f prime of g of h of x times the derivative of g of h of x, which we have down here is g prime of h of x, times h prime of x. So this would be an extended version, if you will, of our chain rule. So our conclusion again being the derivative of f of g of h of x, f prime of g of h of x times g prime of h of x times h prime of x.